Hello everyone, welcome to today's session on statistics for data science. If you are diving into data science, you must understand statistics. It's what helps us to analyze data, make decisions, and even build machine learning models. In this video, we will cover what statistics is, why it matters in data science, and dive into key concepts like mean, median, mode, variance, standard deviation, normal distribution. So we will also discuss the empirical rule, quartiles, percentiles, deciles, outliers, and RFM segmentation. This will be a detailed and practical session, so stay tuned with me till the end. So what is statistics? Statistics is the science of collecting, organizing, analyzing, and interpreting data. We have to collect the data, means what this term statistics, in that what it happens like we have to collect the data. Collecting the data from different sources, then we have to organize that data because data is in different forms, and from data we have to extract information. So to extract information, we should arrange that data in the proper format. Then we should organize, means like we have organized it, and now we should analyze it. We should remove whatever the insights we want from that data and interpreting that data. Interpreting means we have to make assumption from that data. Like we can, if we have the data which is 98% right, so then we can, based on that, we can make decision. If that data is not that much accurate. Okay, so we can take the decisions based on that. So interpreting based on data. So that is what statistics is. It is collecting, organizing, analyzing, and interpreting data. It helps us make sense of raw information. Whatever raw information is present with us, means like bulk of data, means data is present in many different forms. So removing the important thing from that is known as information. So in data science, statistics is crucial for understanding patterns, detecting anomalies, and making predictions. So it helps us derive meaningful insights from data and ensures accuracy and reliability. In short, just we want to make decision based on something we have that data, and based on that we have to make decision. So how much that data is correct, or in that data there are anomalies, or we can get negative response, or we can get positive response based on that data. We are going to think about these things and then make the decision. So it ensures accuracy and reliability. So what happens in statistics? There are two main types of statistics, that is descriptive statistics and inferential statistics. So in descriptive statistics, what happens? It summarizes and presents data. Means like, think of it like we are having numerical data. In a data we are having columns, and that numerical values are present. Like students who have scored in the exam, that their marks are being stored in one of the column. So we can remove mean of that data, we can remove median of that data, we can remove mode of that data. So these things helps us to summarize the data, and then we are going to present that data. That is what descriptive statistics comes with. So descriptive statistics summarizes and presents data. For example, we have mean, median, mode, standard deviation, and variance in that. We'll learn about this mean, median also. Inferential statistics, what happens in that? In that, we make predictions using data. In inferential statistics, we have data, and based on that data, we are going to apply some of the things on that data, and then we are going to make predictions based on that data. In that, we have hypothesis testing, confidence intervals, probability distributions. These things are present. Working with these things, we are going to make predictions based on that data. It's like in both the things, common thing is that we have data, and on that data we are working and removing the things whichever we want. So in statistics we have descriptive statistics and inferential statistics. In descriptive statistics we have mean, median, mode, standard deviation, variance. Those things are there. In inferential statistics we have hypothesis testing, and rest of the things are also there, but hypothesis testing is important. Okay, we'll learn about it in the depth. In descriptive statistics, we summarize the data, and in inferential statistics, we make predictions using data. Next, we are going to learn about measures of central tendency. So, what are the measures of central tendency? It comes in the descriptive statistics that I have told, right? Like mean, median, mode, these all things comes under descriptive statistics. So, in descriptive statistics also we have measures of central tendency, and another thing is also there, measures of dispersion. So I'll talk about that, but first learn about these things. First we have mean in that. Mean means removing the average of the things. Like if we are having data in the columns, like I told before only, the example that students marks stored in one of the column. Okay, think of it like we have 5 numbers like 1, 2, 3, 4, 5 in that one particular column. So we have to add all the values and then divide by the number of values present in it. So that is what removing means formula is. What mean is, mean means average, and what happens, it's simply the sum of the values divided by the number of the values. For example, if we're in a one column or in list or whatever you have to take, you can take it. I'll take it as column. Okay, so in one column I am having the values of 2, 3, 4. Okay, so what it is going to do is, it is going to add all the values, that is 9 divided by 3. It's like 4 plus 3 plus 2, then it will be 9. 9 divided by number of values. How many values do we have? We have 3 values, right? So number of values, so it will be 9 divided by 3, and then 9 divided by 3 we will get the answer as 3. So 3 is the mean, or it is the average of that column. Okay. Then now median. What happens in median? Median means middle value. The middlemost value of that column we have to find, and for median we have 2 different formulas. That is, if we have odd numbers, then it will be n plus 1 divided by 2, and if we have even number, then it will be like n divided by 2. N is the number we are having, means like count of the numbers we are having. The middle value when data is sorted. Yeah, here the most important thing is that we have to sort the data. Like, okay, we took the example of the things, that is 2 plus 3 plus 4 plus 5. Okay, these are the values present in the column. Okay, so we have to arrange them in the ascending order first. Okay, so we will take the example like 1, 3, 5, 7, 9. These are the numbers I have with me. Okay, these are the values, or we can consider it as data. So we have this data 1, 3, 5, 7, 9. So now in that, what I will do is I'll arrange them in ascending order. They are first only arranged in the ascending order. Okay, so now I have to count how many numbers are present with us. So we are having 5 numbers. Okay, so 5 divided by, and 5 is odd number, right? So 5 plus 1, 6 divided by 2, what it will be? 3. So third most value, that is 5, we are having in our data. It is the median. It is the middle value of our data. Now mode. Mode means the most frequent value. In a data set, the value which is being repeated again and again, that is going to be the mode. And we can simply observe it, but if we are having the large data set, then we have to find it. For that we are having formulas in Excel also, but we should know what mode is. Mode is the most frequent value. The value appearing most often in our data is known as mode. For example, if we are having 2, 3, 3, 4, 5, so 3 is being repeated in this, right? So our mode is 3. So now here you can see that this is a chart. So I'll tell about this chart. Okay, this is a histogram showing mode. So this is a histogram, which is a type of bar chart used to represent the distribution of numerical data. I am having values and frequency. In the above here it is showing this red dotted line. It is known as mode. Okay, and mode is equals to 10, means 10 is the most appeared value in our data. Okay, so it is showing that. So I'll tell about this chart also. Okay, so it is a type of bar chart. Histogram is type of bar chart, and it is used to represent the distribution of numerical data. We should know what chart is used to represent what things. So histogram is used to represent numerical data. Okay, it shows how often different values appears in data set. Like we are having data set means these values are being values means data set. Okay, the x-axis horizontal here means like which values have been written over that represents the values of the data set, and the y-axis vertical represents the frequency, like how many times each value or range of the value appears. Okay, so what are the key elements in this histogram? This is bars are there, the smooth line is there, that blue curve. This is called as KD, okay, kernel density estimate. It helps us to visualize the shape of the data distribution smoothly rather than just relying on bars. Okay, with the help of this curve also we can understand the things. And this is called as KD, that is kernel density estimate. And this red dashed line, this marks the mode, which is the most frequently occurring value in the data set. In this case, the mode is 10. Okay, it is already written in the upside that the mode is 10 because it is we can see it, right? Meaning the value that 10, this is appeared most in the data set. Where the mode is written, mode is equals to 10, it is written, it is the legend in the top right. Okay, this tells us that what the red dashed line represent, it is the mode. So what this histogram is telling us, the dataset has the perk around the value 10, meaning the 10 is most frequent number in the dataset. The data is spread out across values from 5 to 30, means like in that dataset we have the values from 5 to 30. And the smooth KDE line helps us to see the overall shape of the data distribution. Okay, means this line is, this curve is telling us that 5 is represented, means 30 is the value which is represented the least, 25 is there, then like how it is increasing and decreasing. We can, with that also we can understand that in our data which values are repeated, which values are not repeated, like that. Okay, so why is this important? Understanding the mode and data distribution helps in data analysis. It tells us where most of our values lie and if the data is skewed. What is skewed? I'll explain it, but for right now, skewed means in one side, leaning more towards one side, or evenly spread. Means in skewed also we have types. We'll learn about that in the next video. Okay, this is useful in many fields including business analytics, statistics, and data science. So now next we are going to learn about measures of dispersion, that is variance and standard deviation. These falls under descriptive statistics only. In descriptive statistics we have two things, that is measures of central tendency and measures of dispersion. In that, in measures of central tendency we have mean, median, mode, and in measures of dispersion we have variance and standard deviation. Now variance itself is telling like what it is. Okay, variance tells us that how much data varies from the mean. Mean we know what it is, right? It is the average. From the average, anything that is following out of that range. Okay, anything that varies from the data, like we have removed mean, and from that mean anything that is very different, so that thing we'll consider as variance. Not we are going to consider, it is variance. Okay, so it tells us how much data varies from the mean. A higher variance means data is more spread out. Next is standard deviation. So what standard deviation is, it measures the spread of values in dataset. Now variance is telling that the value is spread or not. Okay, in standard deviation what it tells, it measures that thing. Okay, it measures the spread of values in dataset. A lower standard deviation means the values are closer to the mean. Okay, when first we have to remove mean, median, those things, and if in that also we are getting any error or spread out values, then we are coming with this variance and standard deviation. Okay, so variance is what? It tells us how much the value is spread out from the mean, and standard deviation is what? It measures the spread out values. Okay, here you can see this bell curve normal distribution and standard deviation. Okay, I'll explain this. This is bell curve, also known as normal distribution. Bell curve because its shape is also right like that only. So this is a bell curve. It is also known as normal distribution, and it is one of the most important concepts in statistics and probability, because many natural and real world data points like test scores, heights, IQ levels, etc. follow this pattern. Okay. So what are the key elements in this graph? The blue color normal distribution curve, you can see that what it is representing, it is the symmetrical and bell shaped curve. It represents that how data points are distributed, and the highest point means the peak one, that represents the mean of the data. Okay, this red dashed line, you can see that this red dashed line, this marks the center of the distribution where the average values lies, and in the normal distribution the mean, median and mode are the same. Okay, and the shaded blue color part, you can see the shaded blue regions, standard deviation. These represents different range of standard deviation. Now in standard deviation also we have the light blue color, you can see that is known as which contains 68% of the data. The medium blue color, it is containing 95% of the data, and the dark blue, it is going to represent the 99.7% of the data. You are going to understand the 68, 95 and 99.7% like it will come further also when we are going to learn inferential statistics. In that also we are going to understand these things. This means most of the data, about 99.7%, is within 3 standard deviations from mean. So what are the x-axis, what x-axis is representing and y-axis is representing? The x-axis represents the values of the data set. Y-axis, what it is representing? It is representing how likely a value is to occur. Now what this graph is telling us, most values are clustered around mean. Okay, means that is 0 in this case, and as you move further from the mean, the probability of those values occurring decreases. And this shape is common in real world scenarios, okay, such as heights of people is also there, test scores is there, measurement errors are there, IQ scores are there. So why this is important? To understand the normal distribution, which helps in many areas like predicting probabilities, like likely someone is to score about 90 on a test or not, identifying outliers. Now what outliers is, that also I'll tell, like values far from the mean. It's like variance, right? Making data driven decisions in the fields like business, finance, healthcare. We need to make the decisions, right? So in that also it will help us. Next we are going to learn about quartiles, percentiles and deciles. So what quartiles are? Quartiles divides the data into 4 equal parts, that is Q1, Q2, Q3, Q4, and which helps us to understand data distribution. Okay, now consider we have the data like we have 1000 records or 1000 rows, like that we have data. So what we are going to do is we have to divide this data into 4 different parts. So if we are going to work on one part only, like we are going to work on Q1 part, and then we can make predictions, or we can make some of the things assume and work with the rest of the blocks, or with the rest of the like Q2, Q3, Q4, with the rest of the things bit easily or bit fastly, right? So in quartiles what happens, we divide the data into 4 different equal parts. Okay, like Q1 is the first quartile, it contains 25% of the data. Okay, Q2 will be the second quartile, that is median. Okay, it will be always median. Median is the middle value, right? And if we are dividing the data, okay, in equal parts, okay, so median, the middlemost value, will lie in the second quartile. Okay, so 50% of the data is below this point, second quartile. Okay, and in third quartile 75% of the data will come. 75% of data is below this point. So quartiles helps in detecting outliers and understanding data spread, means variance, right? How much the data is spreaded, or how much the data is different from the normal things, that we can understand. So if we can take an example, if test scores are like 50, 60, 70, 80, 90, then q1 is equals to 60, q2 will be the middlemost value, okay, that is 70, q3 will be the 80. So like that we have divided the data, okay. 50, 60 will lie in q1, 70 will lie in q2, 80, 90 will lie in this q3. Now percentile. Percentile shows the relative standing of a value in dataset. For example, okay, if your test score is in the 90th percentile, it means you scored better than 90% of the students, okay. Percentiles are widely used in exams, medical tests, and statistical analysis. So if we have to take example of percentile, what we are going to take is, if in an entrance exam your percentile rank is 80, okay, then 80% of the candidates scored below you. So like that also we can, it will help us to make the results more fastly, right? Now next we'll learn about deciles. Deciles means divide the data into 10 equal parts. In quartiles we have divided the data into 4 equal parts, but in deciles we are dividing the data into 10 equal parts, okay. So now I told that we have the suppose we have data into 1000 rows, or like that we have 1000 rows. So what we are going to do is, we are going to divide the data, means like 100 rows in one block, then again 100 rows in second block. So like that we are dividing the data into 10 different blocks. So 1000 rows were there and we have divided into 10 equal parts, like taking in 100 per, right. Deciles provide finer granularity compared to quartiles. Like in quartiles we were having only 4 different parts, but in deciles we are having 10 equal parts. For example, the fourth decile represents the value below which 40% of data lies, right. We can take an example. If salary data is analyzed and your earnings are in the 8th decile, you earn more than 80% of the population, okay. In an organization we can do this, right, when we want to know someone's salary. Now next learn about what is normal distribution. A normal distribution, it is also known as Gaussian distribution. It is probability distribution that is symmetric around its mean. Means like when data is plotted, it forms a bell-shaped curve. We have seen a curve, right? Meaning most of the data points are concentrated around the mean and fewer value appears as we move away from it. So what are the characteristics of normal distribution? It is symmetric, means that the left and right side of the curves are mirror images. Mean, median, mode are equal in this, okay. When we were seeing that bell-shaped curve shape, like that chart we were viewing, in that we were having mean, the middlemost value, means like 0 was the mean, right. So mean, median and mode are equal. These 3 central tendency measures are all located at the center of the distribution, and it follows the empirical rule. We are going to discuss about the empirical rule. A symphotic nature means the tail of the curve approaches but never touch the horizontal axis, okay. And it is defined by the 2 different parameters, that is mean and standard deviation. Mean we know, standard deviation we know, right. If we want to take any real world example of normal distributions, means the bell-shaped curve, the height of the people we can take. Like if you measure the heights of large group of people, you will find that most of the people's height is close to the average only, but only some people will be like that they are extremely tall or they are extremely short. Like IQ score is also there. IQ scores in the general population follow a normal distribution with a mean of 100 and a standard deviation of 15, means like 15 is spread out value and most of them are in the normal flow only, right. Blood pressure reading is also an example. Now let's discuss about empirical rule. Empirical rule means like 68, 95 and 99.7 rule. It is also known as like that, okay. 68, 95 and 99.7 rule. Now that we understand what a normal distribution is, let's talk about the empirical rule, which helps us to understand how data is spread within the normal distribution. Means like normal distribution is there, okay, and in that how this data is spread, that lies under empirical rule. This rule states that the normal distribution 68% of the data falls within the first standard deviations, means there are standard deviations. First one, in that 68% of data will lie, okay. In 95% of the data falls within the second standard deviation of the mean, and 99.7% of data will lie in third standard deviation. Okay, so let's take example of this, then you'll understand it in clear. Let's say the average score in math is 70 with standard deviation of 10. So within first standard deviation, the range is 60 to 80. Okay, means like 68% of students scored between 60 and 80. Within second standard deviation, the range is going to be 50 to 90, means 95% of student has been scored between 50 and 90. And in third standard deviation, the range is 40 to 100, means like 99.7% of students scored between 40 and 100, means from this we can understand like if it is 100% result or not, right? This rule helps us to understand how likely it is to find a data point within a certain range. So, but why this empirical rule is important? It helps us in understanding data distribution. It allows statisticians and analysts to make predictions about data. And it is widely used in the quality control, finance, health sciences, and social sciences also. If you want to take any real life example, then what we can do is, imagine you are a doctor, okay. Let's take again an example so that you can understand a bit. Imagine you are a doctor and analyzing cholesterol levels. If the average cholesterol level is 200 within the standard deviation of 20, so you can predict, right? Means like 68% of people will have cholesterol levels between 180 and 220. 95% of people will have cholesterol levels between 160 and 240, and 99.7% of people will have cholesterol levels between 140 and 260. This helps in setting. So what it is going to tell a doctor? It's like you are a doctor, okay, so what it is going to tell you? This helps in setting medical guidelines and diagnosing abnormalities, okay. So what is RFM segmentation? RFM stands for recency, frequency, and monetary, which helps business segment customers based on their purchasing behavior. It is important and it is used in most of the scenarios, okay. We can take the example of any store and how recently that person is coming and purchasing the things from our store, okay. That will be come in recency. In frequency, what it is going to happen, that how often a customer makes purchase. These things sounds like same, but they are different, okay. How recently a customer make a purchase and how often a customer make purchase, okay. In monetary value, how much a customer spends. So these things are different: recency, frequency, and monetary. So if we have to take a real world example, what we can take as, imagine an online store wants to categorize its customer, okay. So high frequency, high recency, high monetary value will be like loyal VIP customers. We can segregate them into that things. Means like if there is high recency, high frequency, and high monetary value, then we have the loyal VIP customers. Next, if high recency is there, low frequency is there, and low monetary value is there, then the new customers which are coming to the store, okay, we can categorize them into that. If we are having low recency, low frequency, and low monetary value, then the customers, like inactive customers, like they have made one time purchase and after that they have not showed their faces only again. So like that, inactive customers are also there. So based on this, we are categorizing the customers, their purchasing behaviors, and then we can understand, like we can tell them about the offers, or like that we can make a sale more or make decision based on that data, right? So why this RFM is useful? Because businesses can use RFM to target promotion, increase customer retention, and personalize marketing efforts also. So for example, if Amazon segments customers based on purchase habits and suggest products accordingly, right? There it can be used, right? This RFM segmentation. It's like in 2 points there were the concept of outliers. So I'll tell what are outliers. Okay. So outliers are the data points that differ significantly from the values in dataset. Means it is not like variance, okay? Those are the data points that differ significantly from other values in data. What happens when the outlier is there? They can distort statistical analysis. We cannot make proper decision because of those outliers. So it is important to identify them and handle them. So for example, if in a data set like one, we have the values like 1 2 3 4 5 and 100. So the value 100 is an outlier because it is not following the normal range, right? So that is why it is an outlier. So why does this outliers matters? Because outliers can skew the results of statistical measures like mean and standard deviation, so making them less representative of the overall data. Example, like if in an organization there is just a small department and their salary should be like not compared to other departments or the big departments, right? So but when we have analyzed the things, when we have calculated the things, then their salary is being showing like highest from every department. So this is something like not normal, right? So there this concept of outlier comes. So how we are going to handle these outliers? In practice, you might remove or adjust outliers based on the domain knowledge and context. Means like if we are having any requirement or we have been told some of the things to change, then we can make the things, right? We can change, remove, anything we can do. We have seen in the data cleaning things, right? With the Python. So you can also use statistical methods like z-scores is there or IQR range is there to detect and handle outliers. So what does z-scores and IQR is that we are going to see in the next video. IQR is interquartile range. How it is being quartiled or what does ranges, we are going to understand the things in deep. So that's a wrap on our session on statistics today. If you found this helpful, give it a thumbs up, share it with others, and subscribe for more data science content. Drop a comment below if you have any questions or suggestions for my next video. Thank you for watching and I'll see you in the next video. Until then, happy coding!